Hello, welcome back. It's been a few days since I made a video, so I figured I'd do another live solve here. In case you're wondering, I have been pretty busy with some other non-Sudoku related things, and so I haven't had as much time to make videos, but I am still trying to make time to do so. And because it's the weekend, hopefully I'll be able to make a couple in a row here. We'll see how things go. I am also still trying to put together the next Learn to Love Sudoku series. I like to release puzzle packs with those, and of course as the techniques get more difficult, it becomes more difficult to find puzzles that depend on just those techniques. So I am still working on that and trying to put that together. Do let me know in the comments if you're looking forward to that. Maybe it'll motivate me to get it out sooner. Other than that, I do want to kind of explain one thing, which is, I don't know if anyone actually is questioning this, but why do I keep using the same few constructors over and over again? There are a lot of constructors on the Discord and a lot of great puzzles there. And the answer is twofold. One is I did a round where I went and asked permission from certain constructors to use their puzzles on my channel. I always make sure I have permission to use their puzzles and that they're aware that there's going to be a video made, because I don't, I don't want to do that without their permission for several reasons. But in addition to that, they proactively come to me and say, hey, I have another puzzle that I think you'll like, and I think it'll make a good live solve, or I think it'll make a good showcase. And that just makes my job a lot easier than having to go out and hunt and get it tested without doing it myself first, things like that. So if you do have a puzzle that you've constructed and you want it featured on my channel, there's a very good chance that if you just message me on Discord that you will get it featured. I mean, as long as it's, you let me know whether you think it would be a good live solve or a good showcase. If it's a good showcase, let me know what the solve path is. And I will try to make that happen. I do have kind of a queue to go through, but it's not that long, and I'll definitely change it up if I have like a new author, new constructor to feature. So just putting that out there. If you are a constructor yourself, or if you know a constructor who you think would want to be featured, have them reach out to me. Please don't suggest puzzles that you didn't make yourself, because I would then have to go and reach out to the author to ask for permission, which I guess I can do, but I'd prefer to get the author's permission directly with them reaching out to me. So yeah, other than that, hope you are enjoying my videos, and with this one, it will be a live solve, like I said. This is just called Thermo Sudoku by Nityant Agarwal, who I've done several of his puzzles at this point, and I know that his puzzles always feature some interesting logic, so I'm looking forward to doing this, especially because it's a pure Thermo Sudoku. So with that, what are the rules? Like I said, it's just a pure Thermo Sudoku, so if you know what that is, you already know the rules. We have normal Sudoku rules applying, as well as we have thermometers on the board. And the thermometers have a bulb end and then the rest of the thermometer. And starting from the bulb end, the digits have to strictly increase. So if I were to put, say, a 2 here, then I'd have to put something larger than 2 here. It doesn't have to be a 3. It could be, say, a 4. And then I'd have to increase from there. Maybe I could do 5 here, and then 7, and then 9. And then that would be a valid thermo. But I couldn't say, I don't know if that's relevant on any of these. Yeah. Well, either way, I couldn't repeat a digit next to each other on the thermo, and I can't go down. So I can't do like 2 and then 1. And F puzzles will enforce the thermometers. So as long as you get the whole board filled without any red digits and your clock turns green, then you've solved it. So those are the rules. And with that, I will get started. So there's a couple things to always look for when you first start a thermometer Sudoku. And it is not to just immediately start filling all the candidates, although sometimes I will do it on some of these larger ones. But first thing I like to do is I just like to take a little census of like, okay, how long are these? So I look at ones that look the longest, which sometimes is a little bit, what's the word, unclear, which one is going to be more, which is longer than others, because you get diagonals and anyway. So I'm just going to count. So 1, 2, 3, 4, 5, 6, 7, 8. So this one's 8 long. So I think it is worthwhile on an 8 long one to just quickly fill out the specific candidates that are available. Did I count wrong? No, I just repeated that. There we go. So there's a couple of ways you can do candidates on a thermometer. One way is to just start with 1 and work your way up to the end, and then start with 9 and work your way back down to the beginning, and then fill in the intermediates. That's sort of the brainless way to do it, and honestly, sometimes the more gets you the more correct results. The mathematical way to do it is to count how many there are in the thermometer. In this case, there's 8. And then you do 9 minus that number. So in that case, that's 1. And that's how many degrees of freedom you have. And so you fill 1 plus the number of degrees of freedom as candidates into the thermo. And degrees of freedom are nice to keep track of because it means that only one, basically we can only be missing 1 number from this whole thermo is a good way to consider that. So we have 1 degree of freedom. And once we've used that up, the rest of the thermometer is guaranteed to be specific numbers. Okay, so that one was 8. 1, 2, 3, 4, 5, 6, 7. This one's 7. I'm not going to fill that yet. I don't like to just clutter the board immediately. This one's 5 long. This one's also 5 long. This one's 6 long. So that might be the... So we have an 8. We have a 7. We have a 6. 2 5s. This one's fairly two useless 2s. Well, not useless, but there's not much you can do with them immediately usually. Although the next step I will do may make them useful. So the other thing to consider is on a thermo, a 1 can only go on a bulb. So I mean, they can go somewhere that isn't on a bulb as well, but if a 1 is going to be on a thermo, it's going to be on a bulb. And if a 9 is going to be on a thermo, it's going to be on the end of a thermo. So, for example, in this box here, where can 1 go? Well, we have a thermo taking up most of the box, but none of it is the bulb. The bulb is outside the box. So if we're going to have a 1, it's going to have to be in one of these 2 cells, which means that now none of these can be a 1. So we've actually removed a degree of freedom from this thermometer because it can't start with 1 anymore. Otherwise, there wouldn't be anywhere to put 1 in this box. So actually, these 2 cells are going to be a 1 and whatever value is missing from this thermo. So so for example, if this started with a 2, this would be 3, 4, 5, 6, 7, 8, 9. So I would need to put that 2 in here. If this didn't start with 2, if this started with 1, and then we had the 2 represented here, and say maybe the 3 were missing, then the 3 would go in here with it. So there's not a good way to mark that, but that's a good thing to remember. So we can look at boxes, rows, and columns just to look to see if there's any good places to mark 1s or 9s as missing. So we know that 9 is either going to be here, or it's going to be here, but that's true of every number. It's either going to be where it in one of 2 places on the thermometer, or it's going to be in these middle 2 cells. So I'm looking at this row here because it doesn't have any bulbs on it. So the 1 is going to be in one of these 2 cells. Maybe I'll highlight that for a little bit. It may not be too useful. But if we found that this one's not the 1, then that means this one is the 1. And I am looking to see if there's an obvious X-wing happening here. I'm not seeing it. Oh, the other thing I wanted to mention is I do have a cough, so please forgive me if I do cough a little bit this video. I will try to keep it to a minimum. So 9 in this column is going to be in one of these 2 cells. So that's quite nice because that limits it in this box. So just to go over that again, a 9, if it's on a thermo, has to be at the end of a thermo, and none of these are thermo ends, and none of these are thermo ends. So it's either at the end of this thermo, or it's in this non-thermo cell. What else can we do? I'm not seeing any boxes with significant restrictions. I'm just going to carefully go through each column to make sure I don't miss anything here. I may still miss something, but the 9 in this column is almost restricted enough to mark something, which is interesting, but still not. I don't think this is super useful. Similar situation in this column. It's just too many options there. It almost feels like it's something, but it's a few steps away from being something, maybe. This row is interesting because it's got a big thermo on it. So 1 is going to be in one of those 3 spots. Okay, so I have not seen anything significant to mark on rows or columns. Forgive me if I'm missing something. Hopefully we'll catch it later. I am going to mark some of these longer thermos then and see if anything pops out to me there. So we know this was 2 degrees of freedom. So what I'm going to be looking for here is doubles, triples, quadruples, that sort of thing, which really the only way to kind of find those, at least for me, is to mark the candidates. So this one's 6 long. So we can have 3 degrees of freedom here. And by nature, you gotta have multiple thermometers interacting with each other in order to really get any kind of double or triple, quadruple going on. Because obviously one's not gonna do that to itself unless you have other factors working on it. This one's 5 long, that's quite a bit. I'm wondering about this row here. 4, 5, 6, 7, 8. we're 1 extra. I don't like marking 5s, but I might have to. We have 4 degrees of freedom, so this goes all the way to 5. Yeah, and we knew that 1 was limited. 2 is also limited, so 2 can only be in these 3. 3 is a lot less limited, though. So here's another thing that's really nice to look at with thermos interacting with each other is, for example, there's a lot of forced moves you can look at. So here, if I were to put a 5 here, that would do a lot of forcing on this. It would force the entire thermo, right? So just to go over that, I mean, this is easy enough to see in your head, but if I did 5, 4, 3, 2, 1, like basically if I put a 5 here, that forces 4, 3, 2, 1 for the rest of the thermo. And if you look, now we've used 5, 4, and 3 on this row, and so there's nothing to put in this cell. So what that means is I can say this for sure that this one's not a 5. And I think we might have to end up just whittling down some of these possibilities in this way to create a quadruple or a triple where there wasn't one. So like now I have 6, 7, 8, 9. And I'm wondering if I can somehow eliminate the 6 from here to make a 7, 8, 9 triple, which would then help at least. So the other thing that I'm thinking about is if this were a 3 instead of a 2, then this is a 1-2 pair. And I don't see an effect that would have it at this point, but I think it's interesting to keep that in mind at least. So what would a 6 here mean? It would mean it would mean this, right? So I've eliminated all but 1 degree of freedom. So I would have a 3, 4, 5 triple here. So no matter what, I've created a triple. That's really interesting. Let's see what this 3, 4, 5 triple actually does. It puts a 2 here, and then what's missing? I need a 1, obviously, in the blues, as well as one of the 7, 8, or 9s. That all seems okay, though. I'm not trying to bifurcate here. I'm just looking at the what's forced. So we're either creating a 3, 4, 5 triple in this way, or we're creating a 7, 8, 9 triple this way, but I don't know what that specifically means at this point. Maybe you're smarter than me and do see something with that. There's a similar L-shaped thermo here, so I can fill the same candidates here. I don't think the same 5, 4, 3 issue happens, because these thermos aren't as restricted. So the other way to force is to start this one with 5. So if I did 5, 6, 7, 8, 9, that also doesn't work because of the 7, 8, 9 here. So this one's not 5. I think we can do the same thing here, where this one can't be 6. So if this were 6, we'd still force 7, 8, 9 here. So this isn't 6, and this one's not 7, because if this were 7, again, we'd be 7, 8, 9. So that's helping a little bit. Again, 1's limited to these 3, and then 2 is limited to these 4. I'm wondering about these 3 cells. I don't think there's much I can say about it, like a specific digit that must be there, because the blue cell could also have it, like a 1 or a 2. Well, so I guess what we could say is, whatever this is, it could be a 1 or a 2, or something else. It doesn't. That overflows the other 1 or 2 in here, or both. And I guess I could wonder whether it's okay to have both 1 and 2 down here. That would force this to be 3, 4. So we'd have 3, 4, 4, 5, 5, 6. Like that. So I'd have a 6, 7, 8, 9. I think this would be 5, 6, 7. I think I didn't quite do that right. I think that's right. Yeah, because I can't be... I could do 3, 4, 5, 6, 7. Yeah. So that would actually make a 7, 8, 9 here, and that would force 6, 5, 4, 3. Does that mean I can't put a 4 here? 4, 5, 6. That would make 4, 5, 6, and then I'd have too many cells for 7, 8, 9. That's a good way to put that. Just to go over that again. If this is 4, then this is 5, 6. If this is 4, this is 5, and this is 6. Now, I don't know how I managed to get that. What did I do to remove? Oh yeah, I removed the 5 as a possibility here, but I don't think that actually removes the. Oh yeah, I moved the 5, the 6, and the 7 here because I can't do 7, 8, 9 like that. Sorry, I was just double checking. I was getting confused at how I have more degrees of freedom in some of these cells than others. So going back to this, if this is 4, that does force 5 and 6 because of how we'd removed the top end before. So if this is 4, 5, 6, then this has to be higher than 6 as well as this one. So this would be 7, 8. This would be 7, 8, or this would be 8, 9. So we'd have 7, 8, 9 triple here, and then what would we put here? Or another way to put that is I'd have 7, 8, and 9 in 4 different cells. So this can't be 4. And I think I run into the same problem even with just this being 6. So that's a better way to propagate that down. If this is 6, again, this forces too many 7, 8, 9. So this isn't 6, this isn't 5. And now I think we're starting to get, we don't quite have a triple yet. We're starting to see a lot of stuff line up. Oh, it feels really close, like I'm whittling this away. I also have this here that's almost a quadruple. I wonder if this comes into play. I don't see how it would at this point. I don't want to clutter things too much. I'll feel that later if I get a bit stuck. So I guess the question is, can this be a 4? Like, what would that do? Because that forces 3, 2, 1. So I'd have 4, 3, 2, 1. A 2 here. I'm wondering if it has to do with that forcing the 1 here. I think I'm going to have to write this out. 4, 3, 2, 1. Trying to see what I'm seeing here, because the 1 here does force the 1 up here. And we get the 2 here, which puts the 1 here. And then we get the 5. And then this would be a 6, 7, 8, or 9, which means we'd have to have, like this would be the 6, 7, 8, or 9 to go along with what's left in the row. So that forces this to be 6, 7, 8, 9 quadruple. So that actually does force 5, 4, and 3 like this. But that actually all is working. We know there's a 2 here, and that actually works. Ah, darn. Does it work as well if this is a 2 and we force a 2 here? 2 would force 3, 4, 4, 5. So 2 here, 2 here, 2 here. This would be 3. Let's just write that out. So 2 here puts a 2 here, which forces the 2 to be here and this to be 3. And that forces this whole thing, 4, 5, 6, 7, 8, 9. So this would be the 1, obviously. And then this would be a 4, 5 pair. This would be the 6. 3. I'm sorry for taking this so far, but it actually This also seems to work. I'm obviously not looking at all the consequences of that, but so I'm not going to get too much out of trying to... So a 3 here forces a 3 up here. Is the moral of the story that anything but a 2 here makes this a 2? I'm not sure if that's true. Anyway, that doesn't seem to be the route to go down. So let's find something else. Sorry, I'm just thinking about what this does. 7, 6, 5, 4, 3, 2, 1. I was looking at what that does to ones in this. Is there some kind of relationship between the 9s or the 1s, between all these thermos that I need to recognize? It might be time to fill this one. I don't think it's going to be that helpful. I think I'm right. I was just thinking about how if this is forced to be 2, 1, that forces this to be 1. So this would start with 3. And then this would be 2 or 4. It's a lot to think about, remember. But this being a... Okay, so if this is 7, right, or if at some point we force this to be 3, 2, 1, let's just think about 3, 2, 1 here, then the 2 here means this is 1, and the 3 here means this is 2. So then if this were forced to be 4, this would be 3. We'd have 5, 6. I guess I could say this can't be 7, because if this were 7, 8, 9, then this 7, 8 would have nothing. So this isn't 7. This not being 7, that propagates down. Yeah. So does that help? Not really. Okay, so what is, maybe it has to do with this thermo here. I don't think I want to fill the possibilities, but this row seems like it's restricted. Like we have the 9s restricted here. We also can't have an 8 on any of these thermos. So what is going on in this box? The higher numbers are much more restricted than the lower numbers. If this weren't 7, 8, so if these didn't have a 7 in them, the 7 would have to go here, making 7, 8, 9. Same with 6. If this didn't have a 6 in it, then the 6 would... So is that possible? What am I thinking about? Thinking about 5, 6, 7, 8, 9 here. No, because these can still be... Let me just really quickly visualize that. So what do I have left here? One of these is still 9. So I'd have whatever of 1, 2, 3. So I'd have to have at least one of 3 or 4. One, 2, 3, 4, 8, 9. This 7 actually forces 6, 8, 9 like this. What? Something about F puzzles where it understands something about thermos that isn't immediately obvious to me, but it made that 6 red, so I'm just going to look at it in my head instead of... So this would be 6, 8, 9. I'll just use little numbers. Whoops. And this 6 would force 5, 4, 3, 2, 1. This is, oops, I did that wrong. So we'd have a 1, 7 pair here. What is it that I'm not seeing about this? So then this would have to start with 5. This would be 5, 6, 7, 8, 9, or we'd have the 9 here. I'm gonna be honest, I'm not seeing the problem. Oh, this 5 here, there we go. That's the issue. So that's gonna be a lot easier to see. If this is 5, that forces 6, 7. The 7 forces 6 here, which forces a 5 here. Now we have 2 5s in the column. Okay, so this isn't 5. Unfortunately, that doesn't really give us much more than that. 5, 6, 7, 8, 9. Sorry for being a bit slow on this. I'm not sure what the right approach to this puzzle is. I'm sure you're yelling at me about something. So what about just 6, 7, 8, 9 then? So 6, 7, 8, 9 does the same thing where we get 6, 8, 9 here. We get a 5. That forces the rest of the thermo. So a 7 here, I think in general, a 7 here puts a 7 here. That's just box logic. So we'd have a 7 here and a 1, 7 here. So that would mean this would have to be 2, 3, or 4. A 6 here puts a 6 here. And again, oh, okay, this one can't start with 1 no matter what. Because of my pencil marked 1s, obviously. Would 6, 5, 4, 3, 2 be bad? It's a 1 here. Okay, what am I missing here? This is, I've made no progress in quite a while. I still feel like there's something going on in column 1. Nines are here, 8s are here. 7s are, is that? I mean, I need whatever's missing from these 4, and I need 6, 7, 8, 9. So I need 6, 7, 8, 9, and I need whatever's missing of 1, 2, 3, 4, 5. And the 9s can't go here, the 8s can't go here, and the 7 can't go here. And I really don't want to put 1, 2, 3, 4, 5 in there, but I don't know how else to signify that. And then I think it goes the other way, so it's actually like this, where we have, let's call it A, like X, whatever X is missing of 1, 2, 3, 4, 5 from here, that X is a possibility on all 5 of these cells. Well, no, it's only a possibility here, isn't it? Well, I could do, let's say it were 5, just to give it a number. So let's start by adding 5 to all of these, but obviously we can't do 5. So it's actually, are these forced to be 7, 8, 9? Or I guess this could be 6, 7, 8, like that. So maybe that's helpful. I think this is true. I'm going to go over that again. So if you think about it, this run of 4 in this thermo has to come from 1, 2, 3, 4, 5, and is only going to be missing 1 of those. All of which are less than 6, and only 1 of them is missing. So there's some number less than 6, which we'll call 5. So I'll mark that way here. So we have 1, 2, 3, 4, 5 here. And that can only go in this bulb, or I'm going to just erase this cell, or in this cell. If it's in this cell, if the 1, 2, 3, 4, 5 that's missing here, let's call it X. If X is missing, the X that's missing from here, let's call the number missing from here, let's call that X. If that's here, then that forces 6, 7, 8, 9. There's no other option. The only other option is for X to be here, because if X were here, we'd have to have something less than X here, but they're all taken. So we either have X here, or X here, in which case this is 6, 7, 8, 9, or we have X on the bulb here, in which case this is 6, 7, 7, 8, 8, 9, and then whatever's left over here. So this can be any number, but this can be whatever's missing from 1, 2, 3, 4, 5, and then this can only be 6, 7, 7, 8, or 8, 9. So I wonder if that's helpful. So something to think about is, obviously, I mean, we can just use the row for that, but this thermo is missing 3 digits, which end up here. We know one of the 3 digits it's missing is an 8 or a 9. So we can't have an 8 here. I mean, that's just similar logic to what we've done before, because if an 8 is here, that makes 8, 9, which then removes all possibilities from here. So that propagates downward. So 1 is going to be, I'm going to have 1 as blue already, so 1's in one of those two. Just for the row. Do I highlight where 1's go? Maybe there's something that pops out there. I think there's too many spots. Let's see. There's just so many spots for a 1. This doesn't feel like the right way to do it. But I can give it a stare. So this, okay, this row is also quite limited in where 1 can go. I didn't mark that. So we have this row. We have this row. This row. Is that it? Is this an X-wing? I think it is. So in rows 3 and 4, 1 is limited to the same 2 columns of columns 3 and 9. Just double checking, yeah, because the ones here, that does create an X-wing. So I can actually remove 1 as a possibility from the rest of... There we go. So then this has to be 2. So that forces 2, 3, 4, 5, 6. This isn't 6 or 7. That makes a 7, 8 pair and an 8, 9 pair. So that's not 8, 9, 8. All right. So that's what I was probably looking for this whole time. This isn't 3, so that's not 4, 5, 6. 4 is not available in this row. This can't be 7. What'd I do? There we go. This can't be 7. One is in one of these two. This isn't 6. I wonder if we have something similar with 9s going on. And if you want to learn more about the X-Wing, there is a Learn to Love Sudoku video that I have. It's all about the X-Wing, which you are welcome to watch if you want to learn more about that. What am I missing? So 9 is going to be here. I feel like I should have gotten more from that. Got all of these numbers now. So I've got an X-Wing on 8s here as well, because of the pairs force 8s to be in those same columns. So I can just say 8s in one of those two, like that. I wonder if I should remove my highlight on 1s. That's just confusing me. Okay, well, let's do that. Let's remove the highlights for now. Nine's going one of those 3. What about 8s? Have 8s become interestingly restricted? Not seeing it. What I'm thinking about here is that one of these is because they both have to have an 8. So one of them is 7, 8, and the other is 8, 9. So we either have 7, 8 here, 8, 9 here, or 7, 8 here, 8, 9 here. If this were the 7, 8, then I'd have a 5, 6, 7, 8 quadruple. In fact, this would be forced to be at the 5. This would be the 6. So that would have to actually, yeah, 7, 8 here forces this whole thing, doesn't it? Yeah, and then this would be 1, 9. So let's just take a quick look at that. And then this would be 8, 9 like this. This would be 5. If I can do that, there we go. 3, 4, 5 like that. So this would be 2. These would be 6, 7, 8, 9. This wouldn't be the 9. This would be the 1. I don't see a problem with it. We'd be missing the 5 here, so the 1 would go here. This would be 5, 6. And since this can't be the 5, this would be the 5. So this would be 5. I'm going too far again, but this is not a problem. Well, this is 6, 7, 8, so this would be the 9. Ah, so then there's nowhere for a 9. Is that? Yeah, this could never have been 9. Let's go back. That was a lot. I wonder if I can, so if the 9's not here, the 9's also not here. Is there something I can cleanly state about that? At what point is that visible? It's kind of visible here, at least, where this cell has no value. Can't be 1, 2, 3, 4, or 5. It can't be 6, 7, 8, and it can't be 9. So how much earlier can I see that? Oops. So if neither of these is 9, this is a 5, 6, 7, 8. And so that forces this to be 1, 2, 3, 4. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, all seeing this cell, and a 9 seeing this cell. So it wouldn't have any value. So again, if this is not 9, this is 6, 7, 8. So this is 6, 7, 8. This is 5, 4, 3, 2, 1. How much should be visible? So this cell here sees all of those, so it could only be a 9, but we know it can't be a 9 because the 9's over here. So this has to be the 9. It's the only place that can be 9. Or rather, if it weren't 9, we have that problem. So this is 9, which means this is 8, which means this is 7, this is 8. This is not 7. So this isn't 6, 5, 4, 3. 1, 2 pair now. Nine's going to be up here somewhere. It's one of those 4. Is that all I get from that? Well, progress is progress. As always with these live solves, I'm sure I'm making this more difficult than it needs to be. Quite a difficult puzzle for me. Wondering about 7s. It'd still be here. I remember I wonder if there's more to be said about this cell now. So, well, this is this is now 1, 2, 3, 9, right? And then so the 9 must be down here. So whatever this is, it is here. I think we knew that already. Well, I think we were this could have been 3 earlier when we were looking at that before. So this is a 1, 2, 3, 9 quadruple, basically. So one of these two is an 8. Could have seen that from the box. What can this be? I think it can be any of 1, 2, 3, 5, 6, or 7. Well, what about this one? One, two, three, four. That's it. Wow, this puzzle is still like not even close to done, I don't think. I think there's still a lot to do. But maybe it'll start collapsing more quickly if I get more of this resolved. What am I not looking at, I guess is the question. 9 in this row has to go in one of these two. I've seen that in a few other ways as well. So this is basically 1, 2, 3, 4, or 9. Ah, okay. Yeah, this can't be 3. Should have seen that earlier. It's the same logic we've been doing over and over again. If this is 3, 2, 1, this can't be anything. So this has to be 5. Oops, 5, 6, 7. Yes, I know it can't be a 2. Thank you. So then this is 1, 2, 3. Did that give me anything? Well, this 7 means this can't be 7. This isn't 6, 5. The smallest of deductions. Amazingly, this didn't line up with practically anything. Okay, well, this can't be 5. This can't be 6. Even smaller deductions. It does limit 7 quite a bit more in this box, but not enough to do anything useful. Wonder if there's something with this. This is 8 plus whatever's missing here. That much is probably obvious though. But, okay, so we can't have a 5, 6, or 7, so this has to be 8, 4, doesn't it? Am I thinking about that right? I think I am. So imagine the 4 were here. If this were 4, no. Sorry, imagine if the 4 were not here. No, that's not right either. Maybe I am not thinking about this right. Well, okay, well, where do 5, 6, and 7 go in this box? That's kind of what I'm seeing. Because 5, 6, 7, yeah, 5, 6, 7 are eliminated from these two triples. And so when we have two triples like this has to also be a triple. So this is 5, 6, 7. There's only one way to do that on a thermo. So then this is 1, 2, 3, 8. I'm a bit worried. Oh wait, no, there's a 4 here, sir. This is 4, 8. Sorry. That makes more sense. I was really worried about 4, but it's because I did this wrong. This is 4, 8. It's the only place 4 and 8 can go in the box, or in the row. Sorry. In this row, where do 4 and 8 go? Only here. Can't put it here because of the thermo. Can't put it here because we have 4, 8 in the box. So this is 4, 8. So this is not 4. This is not 4. So this is not 3. That means 4 is one of these two. I was really worried for a second that I made a mistake and would have to go back, but no, I'm fine. That's not 7 because of the 7. Okay, we know this isn't 5 anymore. This 2, 3 is eliminated here. Okay, so where do 7, 8, 9 go in this box? They can't go in this cell because of the 7, 8, 9 here. There's only 3 cells left for it. So this is, that's actually huge. This is 7, 8, 9 like this, which makes a 7, 8, 9 triple. So this is the 6, and this is the one that's missing from here. So this makes a 1, 2, 3, 4 quadruple. What else does that do? It gets a 7, 8, 9 triple here. So this is whatever's missing from here. And so it's not a 2 or a 3. So it's a 1 or a 4 or 5 or 6. But it's not 4 or 5 either. So only the 1 or 6 is missing from this string. So it's either 1 through 5 or 2 through 6. That's actually kind of interesting. I don't see how to use that yet. But it means as soon as I get a number, I'll be able to fill all the rest of them. So what's this? This is, we have a 1, 2 pair. So this is from 3, 4, 5, 6. Actually, I have a 6. 6 in one of these two. What is the next deduction? Well, only one of these can start with 1. The other one's going to start with 6 or higher. And this can't be 7 or 8. So if this started with 6, this would be 7, 8, and this would be 9. This can't start with 7. So I think this is 1 or 6. That makes a 1, 6 pair. Let's let's double check that. Obviously, it can be 1. That doesn't restrict this thermo at all. Can't be 2 through 5. 6 works just barely because I can do a 7 or an 8 here and then a 9 here, and there's no problem with having a 9 here. but I can't have a 7 or an 8 here is the issue. So then if I start with 7, then 7 would be the maximum this thermo could ever be. That would force 8, 9 like that, which actually also works. Darn it, okay. So that's a 1, 6, or 7. What was I thinking about with that? If this is a 1, this does not have to be 9. This could still be, maybe I was thinking about it the other way, 6, 5, 4. Anyway, darn, it's not quite a 1, 6 pair. Would have been nice. Well, okay, so, but there's another reason it can't be 7, 8, 9, that's here. So if this were 7, this would be 8, 9, which is okay from these, but then this would be 7, 8. This 7, 8 would have nothing to fill, because this would be 7, 8, 9. So this isn't a 7, so that is a 1, 6 pair. So this is the 9. Which is a deduction. So what's left here? 7 and 8. Means this is 8, 9. If this were a 6, this would make a 7, 8 pair, and the 9 would be used. So that would leave nothing for here. Just to go over that again. If this is 6, this is 7 or 8. So this is 6, this is 7 or 8, this is 9. I now have 6, 7, 8, 9 used, so what goes here? Nothing. So this is the 1. This is a 6. I actually know now that this is 5, 4, 3, 2, 1. Figured that out before. This 2 sees here, that's a 1. And we actually know that that 1 goes here and here. 2, 3 pair puts a 4 here. There are other ways to see that too. That means this isn't 4. This 1 here sees our corner mark, so this is the 1. So this is 2, 3, 2. That was a good deduction there. We got a lot. Pretty happy about that. The 7, 8 pair means this is 9. This is not 9. Whatever's here is also here, right? Yeah, so whatever I put here, where does it go in this box? Well, it's not going to go here, and it's not going to go in any of these because these are too low for it to be a 7 or 8, which means this can't be 9. I guess another way to put that is if I put a 9 here, then this ends up 8, 7, and then what I put here. So this is not 9. Oops. It's a small deduction, but actually that means that this could never have been 9, because 9 has to be in one of these two in the column, so this is the 9. So I probably just had a 7, 8 pair here. I liked my other deduction though. It was fun. Why do the easy thing when you can do the hard thing, right? 7, 8 pair, 3, 4, 5, 6. Okay, what's the next deduction? These aren't 1. This isn't 3. This isn't 2, so this is 3. This is a 2, 9 pair. The 4 C's down here, this is 8, 4. I think we're in the home stretch. I can't believe I just said that, but I think we are. This can't be 4 all the way down. So if that's not 4, that's... No, that doesn't propagate up. This isn't 1 though, and that does propagate. This can't be 5 because that's a 5 or 6. So that's not 6 or 7. 7, 8 pair, so this has to be the 9. I hope I did that right. So then this is the 9. It's based on our corner marks. I think that's most of the 9s. Can we finish them? Not quite. Actually, yes. So this in this box, this is the 9. Because 9 can't be in this column here, so, and it's not on a bulb. So this is the 9. So that's not a 9. That does propagate down a little bit. Have to be very careful. Don't want to make a mistake now. Hopefully I haven't already. 6 in this box is one of these two. It's also one of these two. What's next? I have a lot of 2s. 2's up here. In this box we need a 1, and it's certainly not here because of this one, so the 1 goes here. Very useful thermo right here. Wonder what we used that for at some point. I honestly forget at this point. So the remaining here is 4, 7, 8. Makes a triple. So this is 2, 3, 5, I think. Looks right. The 5 is one of these two. If this were a 5, this would have to be the 6, and that's not going to work. This can't be 7, 8, or 9. So the highest it can be is 6. If this is a 5, this is forced to be 6, and then there's nothing to put here. So this is not 5, which means this is the 5. That means this is 3, 2. So this is 9, 2. We have a lot of 2's now. Two's not here, or so 2 is one of these two. 2, 3 pair, 4, 5, or 4, 7, 8, triple. I think that's a 4, 5, 7, 8 quadruple. No, I have a 6 here as well. So it's not a 4, 5, 7, 8 quadruple. Is this 4, 5, 6, 7, 8? What's missing? A 1, right? That's an easier thing to say. 1 has to go here. It's the only place in the row for it. All right. Again, why do the easy thing when you can do the hard thing? This was the only place for a 1 in the box. I think that's the last one on the board. What's next? I think that means 5 is one of these two. For the row. 5 is one of these two. So this is not 5. So 5 is one of these three, or one of these two actually. Yep, you can see that from the box. 1, 3, about 9. Yeah, this is a 5-9 pair. Only places for 5 and 9 in the box. So this is a 6, 7, or 8. So that means 3 is one of these two. We have 5, 9. 4. 3 is one of these two. This puzzle feels done, and yet it's not. I'm not sure what I'm missing here. This is 2, 3, 6, and... No, 2, 3, 4, and 6, right? So this is not a 2. Or a yeah, it could be a 3. Because this could be 2, 3. This isn't 3. This isn't 2. This isn't 6. What am I not seeing? Four in this box is here. I guess I might as well just fill it. 4, 5, 6, 7, 8. This is not a 4 or a 6. 7, 8 pair. So this is 5. There we go. These aren't 5. This isn't 5, so this is the 6. Four, 7, 8 left. Six is one of those two. That wasn't enough. All right, let's keep going. I think this is a 2 or a 4. C is 1, 3, 5, 6, 7, 8, 9. So that's a 2, 4 pair. So this is not 4. So this is the 4. Still not enough. Okay, what else can we do? This isn't 6 anymore. So this is the 6. Three's down here somewhere. So this is 3, 7, 8. So this is the 3. Because I see 7 and 8. So this is a 7 or 8. We have a 7, 8 pair in here, so this is 2, 4, 5. This is not 2. 4, 5 pair means this is 3. We're getting it. Wow, okay. I'm just going to highlight all the 7, 8s. Let's do 2 different colors here. Let's do blue and orange. That's blue, that's orange, That's blue, that's orange, blue, blue, oh, what did I do wrong? That's what I did wrong. Like that. This one's orange. If this were a 7-8, it would be blue. Blue's one of these, orange is one of these. Okay, so is that a good argument? Yes. So I've colored all the 7/8s blue and orange. And you can see that this cell sees both a blue and an orange. So no matter if this were a 7 or an 8, it would make both blue and orange the same of 7 or 8. So this must be a 6. I'm wondering if there's a simpler way to see that, but I'll just use it. So this is a 6. So this is 7, 8, 7, 8. All the oranges are 8. All the blues are 7. I can get rid of the highlighting now. So this is 4. I said 4, 8, 4, 5, 6, 4, 2, 5, 4, 3, 2, 3, 2. All right, and so there is the solution to Thermo Sudoku by Nityant Agarwal. That was quite a difficult thermo. I think it's pretty. It involves strategies that are pretty common in difficult Thermo Sudokus. I don't think there was anything there that was like. I guess I should say there wasn't anything there that's unexpected in a difficult Thermo Sudoku. So it's just a good standard difficult Thermo Sudoku. So good job there. And I always enjoy doing those. I definitely need to improve in looking for those. I should have realized there would be some kind of X-wing much earlier. I think I've actually solved other Thermo Sudokus that create very similar X-wings, and I just didn't look for it soon enough. But getting that X-wing, it still was quite difficult afterwards, and then the ending was fun. I had to do some coloring. So yeah, thank you for the puzzle, and I look forward to solving the next one that you've already suggested for me. And again, if anyone has puzzles that you've created that you want me to solve, contact me on Discord. I will put in the description my Discord information so that you can directly message me. And other than that, thanks for watching.